Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving an equation with complex numbers. First of all, I want to call it an equation, and later on that could turn into something else, something bigger, which is a locus problem. What's the difference? Well, a locus problem is usually kind of describes something that describes a curve, an equation that or a function that you can basically graph. And in most cases, there are infinitely many solutions. In infinitely many cases, actually. Anyways, so we have the absolute value of z equals 3 times the absolute value of z minus 1. Now, of course, we're not talking about the absolute value of a real number here, so you can't really distribute the 3 here, or can you? Something to think about. And then, does that make it any easier? For example, if you had absolute value of z equals the absolute value of 3z minus 3, would that imply z equals 3z minus 3? Are we talking about real numbers? No, because this channel is all about complex numbers, so we're kind of talking about it in the more complex general case. If you're interested in real cases, real numbers, trigonometry, algebra, number theory, then I have another channel. Go ahead and check out Cyber Math, that is cyber with an S. Also consider becoming a member to support the channel. Great, so to be able to solve this problem, we're going to have to talk about the absolute value of a complex number. What is the definition, right? So if you're new to complex numbers, go ahead and check out my lecture videos and always ask questions. So the absolute value of a complex number, if z is equal to, for example, a plus bi, then its absolute value can be defined as the square root of a squared plus b squared. And where does that come from? If you think about a complex number as a point in the coordinate plane, which we can also call the argand plane, and this is considered the imaginary axis, this is considered the real axis, and then we can actually go ahead and connect this to the origin, which gives us the distance from 0, and in this case, that will be the absolute value of z. So if your number is defined as a plus bi, then basically that's what's going to happen. The absolute value is just going to be the distance formula or the Pythagorean theorem, because that's the right angle, right? So how do we use that information, right? We need to talk about two things here, the absolute value of z and the absolute value of z minus 1. So if z is equal to a plus bi, what is z minus 1? But instead of using a plus bi, and no offense, a plus bi, because it's the name of this channel, obviously, right? It has a lot of value. We're going to use z equals x plus yi, because this could just turn out to be a locus problem. And with the locus problems, you want to express it in the Cartesian form, which is with x and y. Doesn't matter, no big deal. At the end, if you want, you can also replace a with x and b with y. Same idea. So if z is equal to that, then z minus 1 is just going to be this number minus 1. But we kind of have to consider the following. If you're trying to find the absolute value of a complex number, you kind of need to separate the real and imaginary parts. Here, the real part is x minus 1, and the imaginary part is y. So in other words, the absolute value of z minus 1 is just going to be the square root of x minus 1 squared plus y squared, which is slightly different from the absolute value of z, which is the square root of x squared plus y squared. So this is all we need. We're going to plug it in, write an equation, and then just solve it. Easy, right? Sounds good. Okay, now let's go ahead and plug everything into our equation. And remember, for those of you who forgot, the absolute value of z equals 3 times the absolute value of z minus 1 was the original problem. Now we're going to go ahead and replace the absolute value of z with the square root of x squared plus y squared. And then on the right-hand side, we're going to write 3 times the absolute value of z minus 1. If you remember, that was the square root of x minus 1 squared plus y squared, right? So we get this equation in terms of x and y, which is good. So we basically go from the complex world to the real world, because now this actually represents an equation in the real world as well. Because it is in the real world, but it's kind of like a two-dimensional world. That's why you can't really graph functions of complex variables, because they're kind of like a, there's some type of structure that maps an ordered pair to another ordered pair. Using some type of rule, which is the function itself, right? Anyways, that's a different story. Maybe we'll do a problem later on about that. I just wanted to mention real quick. So what are we supposed to do at this point, right? So we have this equation, and to be able to solve it, we need to get rid of the radicals, obviously. That's straightforward, right? Let's go ahead and square both sides. And when we do, we're going to end up with x squared plus y squared here. We're going to get a 9 from 3 squared. And then, of course, this expression right here. You can also use brackets if you're confused about these things. I'm not. And just that's going to be the whole thing, right? Now, here's what we need to do. Expand everything on the right-hand side and multiply by 9 to see what happens, right? Okay. So let's go ahead and expand this first. This time I'm going to use brackets. I don't know why. X squared minus 2x plus 1 plus y squared. Maybe I just felt like it, right? Okay. The next thing is we're going to go ahead and distribute. There are no like terms, so we're not going to be able to combine them. We're going to get 9x squared minus 18x plus 9 plus 9y squared. Awesome. Now, since x squared and y squared are bigger on the right-hand side, I'm going to go ahead and subtract these from the right-hand side. In other words, 9x squared minus x squared is just going to be 8x squared. And then 9y squared minus y squared is going to be 8. 9y squared minus y squared is going to be 8y squared. So they have the same coefficient, which is good. And there's no xy term. Do you know what that means? Okay, we'll talk about it in a little bit. Something to do with conic sections. So we have 8x squared, 8y squared on the right-hand side. What else do we have? We have minus 18x, and then plus 9 equals 0. Awesome, right? Okay, so here's a couple different approaches here. You can go ahead and continue with the process, which is basically completing the square. I'm going to show you how to do it in both cases. Or you can divide both sides by 8 and then proceed with that, which is something that I like better, but again, it's totally up to you. Both methods will work, but in my opinion, dividing by 8 will eliminate some of the issues, which is, let me show you. Divide everything by 8, you're going to get x squared plus y squared, which is good. Again, the coefficient of x squared and y squared are the same. What would happen if they were different? You would get a different shape. What would happen? There's a minus sign between them. That will be a different shape. You see, this is all about conic sections, which if you take two cones like this and then intersect them with planes and in different ways, like if you just intersect like this, that's going to be a point. If you intersect like this, it's going to be a circle. If you intersect like this, it's going to be an ellipse, so on and so forth. There's the hyperbolas, parabolas, so on and so forth, right? Those are conic sections, and trust me, in all these years that I taught these topics, that was my least favorite, because you had to memorize these formulas. What is the locus? What is the focus? What is this? What is that? Crazy stuff. Anyways, I never enjoyed teaching it. So, what was I talking about? Okay, we're going to divide everything by 8. 18 divided by 8 is the same as 9 divided by 4. Let's just write it as a fraction, no big deal. I'll show you how to deal with that. And then 9 divided by 8 is just 9/8. And of course, the whole thing is equal to 0, again, because 0 divided by 8 is 0. Beautiful. 0 is awesome, right? Now, here's what we're going to do next. We're going to go ahead and put these two things together. Because what we're about to do is actually going to reveal our function or curve, whatever, and you'll see in a little bit. But we're about to complete the square. Does that make sense? So whenever you have something like x squared plus bx, and this could be a minus sign as well, here's what you need to do. And I think I talked about this before. Look at the coefficient of x, divide by 2 and square it. That's the number you need to add, because it's going to make this a perfect square like this. That's the formula. Memorize it and you'll be happy you did. Now, here we got to find out what number should we add. That pen probably I think I need to change the pen. Let me change it real quick. Okay. So what we need to do next is look at the coefficient of x, right? And notice that I put the negative 9/8 on the right-hand side. Why did I do that? By subtraction, right? I kept it here, but I put the constant. Because I'm about to add something to both sides, so I want the constant here. You could do that later too, but I just like putting it on the right-hand side right away. And now, here's what we have. We need to find out what to add to make it a perfect square. And how do you find it? Find half of this number, so 9/4 divided by 2. Hopefully you know this. This is 9/8, and then you have to square it. So that's the number you need to add, but guess what? You need to add it on both sides. And do not forget the y squared, because we still have it. And then on the right-hand side, we have negative 9/8, but to it, you have to add 9/8 squared. Beautiful. Now let's go ahead and complete this thing. This is going to be 81/64. And just remember that it's the square of a fraction plus y squared. And here, negative 9 over 8 plus 81 over 64. You have to multiply by 8. 81 minus 72 is a 9. 9 over 64 is going to be the result on the right-hand side, which is good because that's also another perfect square. Beautiful. Now, we have this expression, which is, again, a perfect square. And remember, 81 over 64 is 9/8 squared. So we're going to write it like this. Hopefully that makes sense. Plus y squared equals 9 over 64. Again, this doesn't have an xy term. And the coefficients of x squared and y squared are the same. And what we did is called completing the square. So what is this? It's a circle for the reasons mentioned before. So it is a circle. What kind of circle? The center is at 9 over 8, 0, and the radius is 3 over 8. You, by square rooting this, because in the general sense, here's how you can write the equation of a circle. If the center is h, k, and the radius is r, this is how you write the equation. And a lot of times students will ask me, like, how do you memorize all these formulas? Well, by doing this thousands of times, you end up memorizing. Or if you're really committed to using it and memorizing it, you'll memorize it too. But keep using it, and it'll stick, hopefully. But there's a lot of formulas, to be honest with you. So we got our circle, and what is that going to look like? So we're going to be looking at 9 over 8, which is about, if this is 1, it's going to be a little over 1, like 1/8 bigger. So this is going to be our center. And the radius is 3 over 8. So if this is like 9 over 8, the radius is going to be like 1/3 of that distance. So imagine you have a circle that has a really small radius, something like this. Of course, the circle is included, so it's not a dotted line, but dotted line sometimes makes it a little easier to graph it. So basically, all the points on the circle are solutions. And this is a locus problem because we found infinitely many solutions. And guess what? This brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out Cyber Math and A+BI. Happy holidays. Merry Christmas. See you soon. Bye-bye.